Today is 1-4, measuring angles and segments. How many of you have looked at your textbook? You've opened it up and started using it a bit at home here and there. Okay. Online, if you go to the website, there are videos. Like the lesson that I'm teaching right here will actually be on there. That's why I'm at the document camera and not standing at the board for most of it. Otherwise, you couldn't see it. So, also why I use slides, paper slides versus actual PowerPoint slides. But make sure you guys are asking questions if you need any help, and then also make sure that I don't go off the screen here. That's helpful. All right. We'll go through the other assignment here in a few minutes, but first thing I want you to do is I want you to grab a book. I want you to define those things. Probably using a picture is best. Okay, there you go. All right, so what does congruent mean? Carson, what do you got?
Two segments with the same length.
Good. Two of anything that are the same size is congruent. And the symbol we want to use for congruent is this one here. It's an equal sign with a wavy thing over the top. Some people say it's an equal sign with nice hair. Nice. Okay, got the good hair. Okay, so if, for instance, two angles, an angle would be two rays that are connected. Okay, so if an angle, say, let's call this one angle ABC, and we'll go with another angle here. We'll call it angle HIJ. Okay. If those two angles were congruent, we'd show that with a little mark like that in there. That was same. If this one has one arc and that one has one arc, then that means they're congruent. The ones with the same number of arcs in it. If this had two arcs and that one had one arc, now it wouldn't be congruent. Okay. However, since it has that, they are. Sometimes we mark it like this. We put a little marking like that. That also shows that they're congruent. Okay. So we would write that as, we could say angle. That's how we abbreviate angle. Angle ABC. Notice we name this by the middle, the place where it changes directions. The middle letter has to be the place where the angle turns. So ABC is congruent to HIJ, to angle HIJ. Okay. What types of angles are these? Cameron. Those are acute angles. How do we know they're acute? Chase?
They're less than 90 degrees.
Good. Acute means less than 90. Good. Yeah, bigger than 0 for sure. Okay, less than 90 degrees is acute. Okay. What's right? Yeah? 90. Okay, so acute is less than 90. Right is 90. What's straight?
180.
180, yeah. 180 degrees is a straight angle. Okay, it's a straight line. We use that a lot in geometry. 180 degrees. Okay, I like to think of acute as less than 90 degrees. It's one way to think of it. Obtuse. Obtuse. Someone that hasn't volunteered yet and get to know names here. Grace.
Obtuse is basically greater than 80 but lower than 100.
Good. So greater than 90. Less than 180. Dude, there's some crazy birds out there, man. Holy moly. Serious stuff. Okay, so we got obtuse there. So a picture for an obtuse angle may be something like that. All right, now how many of you knew most of those? All right. Okay, very good. Read postulate 1-5, answer questions 7 and 8. We're actually going to go through that stuff together here. But in your notes, if you're keeping notes, what I would do is out in the main idea part, I would write page 25, postulate 1-5. And then if you want to, you can put that information on there. But this is page 25 in postulate 1-5, and you can follow along in your book. But it says the points on a line can be put into a one-to-one correspondence with the real number so that the distance between any 2 points is the absolute value of the difference between corresponding numbers. Which, for some people, that just makes your head spin and hurt. when you start reading stuff like that. But a lot of books, and I want you guys to know how to read a math book, because you're not going to always have a teacher sitting right there that can help you out. You're at home, you're struggling with it. If you're in college, I took a course online this summer that I never met anyone in the course or in the college. It's a pre-calculus course. There were forums that I could talk to. They had to know how to talk and read math. Okay, so I was just taking a brush-up course, so I was a little ahead of it on there. But for those of you, if you haven't had a chance to actually read the book, that's why I say when we have more time and we don't have a cut schedule, when I say open to page 25 and read this, I really want you to read it. And sometimes you'll look at it and you'll go, yeah, I don't understand what they're talking about. And that's okay, but you've read it, and then we'll go through it. That's the point here. It says the length of AB, so that means this length right here, from point A to point B, equals the absolute value. Now, what does absolute value mean? Oh, I had it all last week. All right, you got to help me again with your name. Emily? All right, Emily. Sorry. What's your last name again?
Moran.
Okay, Emily Moran. All right, Emily, go for it.
Absolute value is the number's distance from 0.
Good, it's distance from 0. It's a distance, okay, and distance is always, it's always a positive number. So this just says the positive distance between A and B. So if I knew that A was, say, 3, and B was, say, 7, the distance is 4. Now look, the way they're saying subtract B from A. Well, if I did that, that would actually be 7 minus, or 3 minus 7, which would give me negative 4. Well, we know distance is positive, so the distance between those is positive 4. So that's why they're saying absolute value. Now, how many of you knew that's how you'd figure out distance? Yeah, most of you know this. It's called the ruler postulate. You've done it before. You measure. How many of you have measured something on a ruler? Yeah, that's what you're doing here. Okay? Why do we say things like that? Well, because we have to have some different set guidelines that we're following here. Okay? So let's take a look at this. Number 7, I want you to tell your neighbor, find AB. That means find the length of AB. Notice sometimes they don't put the little line over it. Find AB if the coordinates of point A is negative 8 and the coordinates of point B is 11. I want you to do that right now. You don't have to write it out, but I want you to figure it out. You get 10 seconds, and then you get to tell your neighbor. Okay, time is up. Now, if point A, here's point A. If point A is at negative 8 and point B is at 11, all right? Now, I said you didn't have to draw it out. How many of you find it easier if you draw it out? Yeah. So sometimes when you're struggling, it's nice to draw the picture. I'm trying to make a point here. Some of you will look, and it might not be you, but there are some people out there that will just look at a paper and they'll stare at it. And their face will crinkle, and smoke might start rolling out of their ears, and they start shaking, but then they get the answer, maybe. Okay, it's okay to actually draw a picture on it. So if this is negative 8 and that's 11, what I like to think of is 0 as a guideline. There's 0. Okay, how far is it from 8 to 0? 8. And from 0 to 11? 11, I'm sorry, that's negative 8 to 0. But 8 plus 11 is 19. How many got 19 as your distance? Yeah, that's your distance. Now you could have used the ruler postulate. You could have said 11 minus negative 8, which is 19. You could have said 8 minus 11. Actually, negative 8 minus 11, excuse me. And that would have been, well, that would have been negative 19. What did I forget there?
Absolute value.
Yeah, it's absolute value. It's easy to forget that because we're thinking, well, we know distance is positive. But okay. All right. Any questions on that? Draw the picture to help you out. Try this. Name 2 segments that are congruent. And then name a second pair of congruent segments. There you go. Give it a shot. Write it on your paper. Okay, how many got AB is congruent to, well, what is it congruent to? Yeah, it's congruent to BC. Could I say CB? Good, buddy? Yeah? Yeah, good. Either way is fine. Okay. AB is congruent to CB or BC. How about another set? Yes, sir. That is. Oh man, come on. If I took a minute, give me your first letter. I knew that. Give me your first letter, your last name. Your second letter A? All right, help me out. Okay, go ahead, Julian. C, D, and D, E. See, this is why I'm all for like 7-day-a-week school, because then it wouldn't have been a layover. You know, I would have been able to get names a little easier. Don't you guys agree?
No. No.
Oh, I think it would have been a good idea. All right, postulate 1-6. If 3 points A, B, and C are collinear, and B is between A and C, then AB plus BC equals AC. You guys got to tell me if that's blurry. I don't know why I just like that. So, by the way, that's the segment addition postulate. So once again, sometimes it's like does statements. You're like, well, if this length and this length make that whole length, then that plus that equals that. That's what they're saying. How many knew that? Yeah. Duh. Okay. So now we try to apply it. Try this. If EG equals 100, that means from here to here is 100. This is why I give you worksheets more in this class, so you can draw over them. Find the value of X, and then find EF, and find FG. Okay, go ahead and work with your partner. You get a few minutes there. Okay, hey, it's interesting walking around, and when I'm walking around, I'm not trying to spy on you. I'm just checking out what you're doing, and which I guess some of you might say that's spying on me, but I'm really trying to figure out where the mistakes are, and usually some mistakes I see is some students say, hey, that part equals that part, and so you set them equal to each other. That's a mistake. Some of you had the correct piece, and some of you were just kind of sitting there going, I don't really know. Okay? Well, we're looking at this. We know that EF plus FG equals EG. Can everyone agree with that? Like this length plus this length add up to that length. Everyone agrees? Yeah? And so EF, well, we have a name for EF. We're calling it 4x minus 20. It's kind of a weird name. Like if your parents named you that, you'd be like, well, thanks, Mom and Dad. And then your sibling, 2x plus 30. Okay? That's what FG is. Okay? So EF, FG, and that equals EG. And they told us EG was 100. Okay? So that's our equation. Now, how many had that equation? A handful you did. Kind of walking around. Okay? Now we're combining like terms. Notice parentheses really don't mean anything right here other than I substituted it in, which is sometimes nice to see that we've done the substitution, especially if you're looking back later. So we got 4x plus 2x gives us 6x. I have a negative 20 and a positive 30, which is 10. Okay, and I'm just simplifying that side. All equals 100. 6x then would have to be, what am I doing from here to get just to 6x? Yes, ma'am?
90.
Yeah, it's 90. What's your name again? Madison. Okay, Madison. Subtract 10, right? Now, I don't always show that step. I figure you made it through algebra. You can do that in your head. Okay? And then we divide by 6. X is? Yeah, it's 15. For those of you who can't do that in your head, how many could do 90 divided by 3 in your head? Okay, you just double that. Or, excuse me, not double it. You cut it in half. Because 6 goes in. Anyway. So, 15. Now, how many got 15? Good. Well, the next part says find EF. Hey, it's right there. But if we put the 15 in, that's 4 times 15. We put that in for the x and actually solve. That gives us 4 times 15 or 60 minus 20 or a total of 40. That's what you meant, right? And if that's 40, what's this one, what better this one be?
60.
Better be 60. Now, that's because 40 plus 60 make 100. Now, if I put 15 in there, I better get 60, which I do. I get 30 plus 30, or 60. Woohoo! Yeah, mano. Dun 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 dun. I know. Any questions there? So fun. All right. I could tell you guys were pumped. So. All right, so this is another postulate here. It's kind of out of order. Let me switch back to this. Let O, so we dealt with segments, and now we're dealing with angles. This is called the Protractor Postulate. Let OA, so from here to here, so this angle, or excuse me, this ray, and OB be opposite rays. Now, opposite rays make what type of line?
Straight.
Straight line. And how many degrees in a straight line?
180.
180, okay? OA and OB and all the rays within point O can be drawn on one side of AB. So in other words, all these rays can be drawn out here. We could just draw a bunch of lines. Okay, they can be paired with 0 to 180. So they correspond to different angle measures on our protractor. Okay, so this one right here, OA is paired with 0, OB is paired with 180. If OC is paired with X and OD is paired with Y, then the measure of COD, angle COD, is the absolute value of X minus Y. That easy, man. How many understand what they're saying? How many are like, I have no idea what they just said? That's just, okay. Yeah, that happens sometimes. So you got to understand. So break it down. OA is paired with 0. Everyone see how that's paired with 0? Yeah, and OB is paired with 180. Everyone see that? Okay, how many are with me still? All right. If OC is paired with X, so in other words, they're saying this is X right here, this whatever degree. Now you can look at that and figure out what degree that is, but they're saying that's X. And they're saying OD is Y. They're saying then this angle measure right here equals the absolute value of that minus that. So it doesn't, but let's pretend for a minute this was 50. And let's pretend for a minute this was 140, just to make them easy. What's 50 minus 140? 50 minus 140 is negative 90. Absolute value of negative 90 is? 90. They would say that this angle was 90 degrees. Now it's not quite because I rounded the measurements, but yeah, dude, that's all they're saying. How many could have figured that out without all the wordiness? Yeah, you could have. Okay, but we need to know how to read and discuss math. That being said, I want you to try this one here. Name angle 1 in 2 other ways. So you get 10 seconds to name that in 2 other ways on your own. Ready, go. I hear some of you saying AEC. Some of you said CEA. That's the same angle, though. So angle AEC works. Anyone get the other one? It's not CEA. Those are the same. We're going to count those as the same. About angle... Yeah. No. Has to be 3. James?
CED.
No. CED would be this one here. Is he?
AED.
No. It's actually angle 1. Because the number there. Yeah.
Well, it says 2 other ways.
Oh, 2 other ways. CEA and... Okay. I see. AEC would work. We got to name angle 1. Could we call it angle E? Yeah, we couldn't because there are 2 angles formed right here. Okay. So let's go with CEA, AEC, and angle 1. I'm sorry. Name CED in 2 other ways. DEC, angle DEC, and angle 2. How about angle E? Nope, couldn't do that. Okay, angle E represents both of those. All right, that's what C says there.
If it was blank, could you call it angle E?
You could, yeah. If it was just, let's cover that up. If it was just that, then yeah, you could. You could call that angle E. If there's only one angle there. Okay. All right. Well, we are going to, I think, be done right there, with the exception of this guy right here. While I'm handing out your assignment, I want you to take a look at number 16 here. And actually, I have one other problem after this, but I can get your assignment out to you. Take a look at that. Talk to your neighbor about it. Name the congruent angle shown at the left. Actually, they're showing down below because I cut and paste this. But from here, which angles are congruent? Carson?
A and C.
A and C are, yeah. How do we know that? Yeah, they have the same number of curved lines at the angle. Haley? No. It'll come your way. There you go. All right. Any other angles that are congruent? Yes.
B and D.
B and D, right here. Okay, any other angles that are congruent? Yes? Good. Now it's easier if we actually say angle E is congruent to angle F, and angle B, actually, angle C is congruent to angle D, okay, and angle A is congruent to angle B, rather than circling all of them like that. Right. Okay. Very good. I want you to go ahead and take a look at your assignment. We're going to do the mixed side. The mixed side there. Right. And yeah, you should be good to go. So I want you to look it over each part for me and read through the directions and make sure there aren't any burning questions that come up right now. Okay? On this number 8 here, since there aren't any other angles coming off this angle, could we call it angle O? And the answer is yep, you can call it angle O because it's the only angle there. That's one way of naming it. Good. Any other questions when you look at it right away, just immediately stand out to you? It's always good to just look down the sheet before you start, before you leave class. Okay, I'll be walking around trying to get